Section 5.2, Composition of Functions. Our goals for this section are to be able to express and evaluate arithmetic of functions, including addition, subtraction, multiplication, and division. We also wish to express and evaluate what is called composition of functions, and we'll see an application. So first, some notation with the arithmetic of functions. If f and g are two functions, where for all x values such that f of x and g of x are defined, we can define the sum, difference, product, and quotient of f and g as four new functions defined as follows. The sum function f plus g of x is equal to f of x plus g of x. The difference function f minus g of x is equal to f of x minus g of x. The product, f times g of x, is f of x times g of x. And the quotient, f over g of x, is f of x divided by g of x, where g of x is not equal to 0. Remember that division by 0 is undefined. Now, when we want to find the domain of these new functions, we often have to look back to the original functions. So for the sum, difference, and product of f and g, the domain will be the set of real numbers x contained in the domains of both f and g. However, if we're dividing, if we have the quotient function, the domain will be the set of real numbers contained in both f and g such that g of x is not equal to 0. So we have to take that into account when we're determining the domain of that quotient function. Alright, so let f of x be 2x squared plus x and g of x equal 3x minus 1. We're asked to find each function and state its domain. And well, first it might be useful to note the domains of these functions. F of x equals 2x squared plus x, that's a quadratic function, and that has domain all real numbers. G of x is a linear function and also has domain all real numbers. Alright, now exercise A asks us to find f plus g of x, which is f of x plus g of x, so that would be 2x squared plus x plus 3x minus 1, or more simply, 2x squared plus 4x minus 1. Now, since the domain of our original functions were both negative infinity to infinity, the domain of the sum function would also be negative infinity to infinity. Exercise B asks us to find the difference of those functions. So we would have 2x squared plus x, subtract 3x minus 1. Now be careful here. Remember, when you subtract a quantity, that subtraction distributes through all the terms. So we would have 2x squared, then I'd have a plus x and a minus 3x. So that's a minus 2x, and then I have a minus negative 1, so plus 1. The domain of this function would also be negative infinity to infinity. The product of f and g is 2x squared plus x times 3x minus 1. And if you remember maybe the FOIL concept, this would give us 6x cubed. Let's see, we'd have an outer term of minus 2x squared and an inner term of plus 3x squared, so that would be a plus x squared. And then we would have a last term of minus x. For the product, the domain is simply whatever is in the domains of f and g. So again, the domain is negative infinity to infinity. And finally, we have the quotient function. F over g of x would be f of x, so that's 2x squared plus x over 3x minus 1. We can't simplify this any. And so we want to determine the domain of this function. Well, remember when we have a quotient, the denominator cannot be 0. So we have to be careful about the domain. So 3x minus 1 cannot be 0, which implies that 3x cannot equal 1, which implies that x cannot equal 1/3. So then we can write the domain as the set of x such that x is not equal to 1/3. We can write the domain using interval notation as -infinity to 1/3 union 1/3 to infinity. All right, let's see an application. A company manufactures and sells DVD stands for homes and offices. The revenue in dollars for the company for X DVD stands sold is modeled by R of X is equal to X by the quantity 65 minus 0.01X. The total cost for producing the stands involves a fixed cost of $600 plus a variable cost of $15 per unit to be sold. Part A asks us to write the cost function C of X for this problem. Alright, so the cost involves a fixed cost and a variable cost per unit. Where X, let's let X be the number of stands, X is the number of units that it will be sold. So then C of X would be 600 plus 15X. What about the profit function? Well, profit is generally written as R minus C of X, revenue minus cost. So then the profit function would be the revenue function, X by 65 minus 0.01X, minus the cost function, 600 plus 15X. Alright, so now if we maybe simplify this a little bit, we would have 65x minus 0.01x squared minus 600 minus 15x. So p of x, the profit function, can be written as negative 0.01x squared plus 50x minus 600. Part C asks us to find and interpret p of 250. So p of 250 would be negative 0.01 by 250 squared plus 50 by 250 minus 600. Using a calculator, I found this expression to be equal to 11,275. So p of 250 is 11,275. And interpret. The profit for selling 250 DVD stands is $11,275. Given f of x is x squared plus 4 and g of x is the square root of x minus 5, find each of the following. F minus g of 9. Well, that would be f of 9 minus g of 9. Now, we could also determine the difference function. We could figure out f minus g of x. Right? We could come up with the function f minus g of x first and then substitute 9. But I think it's easier to just substitute the 9 into each of the individual functions. So that would be 9 squared plus 4. That's f of 9 minus the square root of 9 minus 5. That's g of 9. 9 squared plus 4 is 81 plus 4, that's 85. 9 minus 5 is 4, and the square root of 4 is 2. So 83. F minus g of 9 is 83. F times g of negative 3.5, that would be f of negative 3.5 times g of negative 3.5. Now notice that g of negative 3.5 would mean the square root of negative 3.5 minus 5, and that's the square root of negative 8.5, and so this is a non-real value. F divided by g of 21. That would be f of 21 divided by g of 21. So that would be 21 squared plus 4 divided by the square root of 21 minus 5. Let's see, 21 squared plus 4 ends up being 445. 21 minus 5 is 16, and the square root of 16 is 4. So f over g of 21 is 445 over 4. Use the graph to evaluate f minus g of 0. And here we see this graph of two functions. We see f of x in black and g of x in blue. And we're asked to find f minus g of 0. So remember that that would be f of 0 minus g of 0. Now let's see, f of 0 is 2. G of 0 is negative 2. So that would give me 2 minus negative 2, which is 4. F over g of negative 3. That would be f of negative 3 over g of negative 3. Let's see, f of negative 3, when the input is negative 3, the output is 5. And g of negative 3 is negative 1. So that would give me 5 over negative 1, which is negative 5. Exercise C, we have g over f of 2. That would be g of 2 over f of 2. See, g of 2 is, about 2.4 maybe. Wrong color, that should have been in blue. Alright, so about negative 2.4, and f of 2 is 0. So that gives us negative 2.4 over 0, and that is undefined. So the element 2 is not in the domain of g over f of x. Alright, now that we've talked about arithmetic of functions, we also have something called composition of functions. So if we let f and g be two functions, the composite function f of g, denoted f circle g, is defined as f circle g of x, which is f of g of x, provided that x is in the domain of g and g of x is in the domain of f. Different ways we can say this: f composed with g, the composition of f and g, the composite of f with g. So now, what does this mean? What does this f circle g equals f of g of x mean? We are going to take the output of g of x as the input for f. Take the output of g of x as the input for f. All right, here we have some functions. F of x is 4x plus 5, g of x is x plus 4 over x minus 4, h of s is the square root of x, and r of x is x squared. And we're going to try to find some composite functions and state their domains. All right, so f composed with g of x. Now, I like to use the notation f of g of x. Now, what is the g of x? G of x is, and let's use another color here, just to help us see this. Let me use orange. Now, g of x is x plus 4 over x minus 4. So then this becomes, now f of x is 4x plus 5. So I'm going to replace the x with g of x. So I have 4 g of x plus 5. Now g of x is x plus 4 over x minus 4. Still plus 5. Now we might be able to simplify this a little bit, but after this substitution, it's a good idea to determine the domain. So if I look at this function, notice that I have a division by x minus 4. So that means that x minus 4 cannot equal 0, which implies that x cannot equal 4. And so therefore my domain is a set of x such that x is not equal to 4. Now we can simplify this a little bit. I could maybe write this as 4x plus 16 over x minus 4 plus 5, where I've applied the distributive property. All right, let's determine g composed with f of x. All right, so if we switch over to the other notation, we have g of f of x. Now g of x is x plus 4 over x minus 4. So wherever I had the x, I'm going to replace it with f of x. So then this becomes 4x plus 5 plus 4 over 4x plus 5 minus 4. All right, let's check our domain here. We have this entire denominator that cannot equal 0. So we have 4x plus 5 minus 4 cannot equal 0, which means that 4x plus 1 cannot equal 0. Solving for x, we find that x cannot equal negative 1/4. So therefore our domain is a set of x such that x is not equal to negative 1/4. And we can simplify the function a little bit and say that g composed with f of x is equal to, let's see, 4x plus 5 plus 4 is 4x plus 9. 4x plus 5 minus 4 is 4x plus 1. So g composed f would give us this function on the stated domain. Determine f composed with f of x. Well, that's f of x. Now f of x is 4 times something plus 5. And I'm going to replace the something with f of x. So that would be 4 times 4x plus 5 plus 5. All right, now if we look at this function, there's no divisions to be worried about. There's no square roots to be worrying about. So this will give us a domain of all real numbers. So we have 16x plus 20 plus 5, 16x plus 25 is f compose f of x. And the domain is all reals, negative infinity to infinity. All right, R compose h of x. So I'll think of h as being an orange. So R compose h of x would be, now R of x, so R of h of x. Now R of x is something squared. And the something is h of x. So that would give us, then, the square root of x square. All right, now remember, since our inside, since we have that square root, remember that the domain, then, is x must be greater than or equal to 0. Now, the square root of a number squared is x. So R compose h of x is x, but on the limited domain, x is greater than or equal to 0. All right, so we have to be careful about that. If you just said R compose h of x equals x, and just said, well, since it's just a plain old x, the domain is all real numbers, that would be incorrect, because this is a composition of two functions, one of which has a definite restriction on its domain. What if we were asked to find h compose g of 5? We can find the composition function first and then substitute 5. However, it might be easier to just think of this as h of g of 5. Now g of 5, alright, so this would be h of, now g of 5 would be 5 plus 4 over 5 minus 4, right? Because there's our g function. 5 plus 4 over 5 minus 4, that's 9 over 1. So then this becomes h of 9 over 1, which would become h of 9. Now h of 9 is the square root of 9, which is 3. R compose f of negative 2. That would be R of f of negative 2, which would be R of, now f of negative 2 is 4 by negative 2 plus 5 from the f function. All right, the f function is 4x plus 5, so substituting the negative 2. So then this would become R of, now let's see, 4 times negative 2 is negative 8. Negative 8 plus 5 is negative 3. And R of negative 3, now using the R function, that would be negative 3 squared, which is 9. All right. And let's look at that graph again, but now evaluate some compositions. Again, f of x is in black and g of x is in blue. Let's evaluate f compose g of 0. All right, so that would be f of g of 0. Now g of 0 is negative 2. So then this would become f of negative 2. F of negative 2 is 4, and so this would be 4. So given those functions, f compose g of 0 is 4. All right, let's evaluate G compose F of 5. That would be G of F of 5. So first, let's evaluate F of 5. F of 5 is -3. So this would be G of -3. Now G of -3 is 5. So that would give us then 5. So G compose F of 5 is 5. All right, that concludes the presentation for this section.